So in earlier videos we discussed about some properties of lanthanides. That is first of all we discussed about electronic configuration of lanthanides, then oxidation states of lanthanides, magnetic properties of lanthanides. Then under spectral properties we discussed about the color of lanthanides, absorption spectra of lanthanides, and ability of lanthanides to form the complexes. So in this video, or from this video onwards, we are going to discuss occurrence, extraction and separation of lanthanides. So this is the next chapter in the unit inner transition elements, that is occurrence, extraction and separation of lanthanides. So first of all, lanthanides, earlier they were called rare earths because it was considered that in nature their abundance is very less. So they are rare in abundance and therefore they were called rare earths. But nowadays this term is not used. They are not called rare earths. In fact, lanthanum, cerium, neodymium, these are more common than the lead. And these lanthanides are widely distributed in large number of minerals. And most of the lanthanides, these are associated with minerals of radioactive elements. And these lanthanides occur in the form of silicates, phosphates, titanates, etc. And the important minerals are monazite, it is orthophosphate of lanthanide, and its general formula is LnPO4. It contains 50 to 75% lanthanides along with 3 to 25% thoria, THO2. Another important mineral for lanthanide is gadolinite. Its composition is FeBe2, Ln2, Si2O10. This is the silicate of lanthanide. These are the two important minerals of lanthanides. This gadolinite contain 10 to 60% lanthanides. Basically, monazite, it is processed for the isolation of lanthanides as a byproduct. The main product is thorium. So thorium is obtained from monazite and there is a byproduct of some lanthanides. Especially promethium, it is a radioactive element, radioactive lanthanide. It occurs in trace quantity, that is 10 to the power minus 20 ppm along with the uranium minerals, and it is one of the radioactive element. So out of various lanthanides, promethium is the only radioactive element. Now next point is extraction of lanthanides from monazite. As already I told you, monazite is especially processed for isolation or separation or extraction of thorium, but at the time of extraction of thorium, lanthanides are also obtained or extracted as a byproducts. So there are two steps at the time of extraction of lanthanides from monazite. First is concentration of ore and other is chemical processing or cracking of mineral. Actually, concentration of ore, it is necessary for the purification or removal of gangy part from the ore or mineral, and as soon as mineral is concentrated, then it is processed. So in concentration, first of all, mineral which is taken out from the mines, it is finely ground, then it is washed with stream of water. So during washing with water, some water soluble impurities these are removed from the mineral. Then ore is dried, then it is allowed to have a magnetic separation. So during magnetic separation, the magnetic materials, these are removed from or separated from the monazite mineral. So magnetic belt is used for the separation of magnetic material. So after magnetic separation, we get the concentrated monazite mineral. So in this way, once mineral is concentrated, next step is cracking of mineral or chemical treatment, or it is also called as processing. So main steps of processing are, first of all, concentrated mineral, it is heated with 93% sulfuric acid for 4 hours, and the temperature maintained is 483 Kelvin. So when this mineral containing lanthanide ions and thorium, it is treated with 93% sulfuric acid, the lanthanide ions are converted into sulfates of lanthanides, and thorium, it is converted into thorium sulfate, and therefore there is a formation of paste of sulfates of lanthanides and thorium. So we get a solid paste or precipitate of sulfates of lanthanides and thorium. So this paste, it is then leached with water for 12 to 15 hours. Just water is added to this paste and the mixture is stirred for 12 to 15 hours. So slowly this paste, it is converted into soluble sulfates of lanthanide plus 3 and thorium plus 4 ions. So this paste or precipitate gets dissolved and we get soluble sulfates of lanthanide ions along with thorium sulfates. Then this soluble sulfates of lanthanide and thorium, it is treated with sodium pyrophosphate, and there is a formation of respective pyrophosphates of lanthanide and thorium. So thorium pyrophosphate, it is a solid, so it gets precipitated. Earlier thorium sulfate, it is in dissolved condition. When it comes in contact with, or when it reacts with sodium pyrophosphate, there is a formation of precipitate of thorium pyrophosphate, and lanthanum pyrophosphate remain in the filtrate, which is treated with oxalic acid. So sufficient quantity of, actually this solid is separated and this filtrate, it is treated with oxalic acid. So this solid mainly contain thorium. So thorium is extracted or purified from this thorium pyrophosphate to the filtrate containing dissolved condition, or in dissolved condition there are lanthanum sulfates and lanthanum phosphates, pyrophosphates. So it is treated with oxalic acid and there is a formation of solid lanthanum oxalates, Ln2C2O4 thrice, along with trace amount of solid thorium oxalate. In this filtrate, some thorium is also there, thorium sulfate, which combines with oxalic acid, and there is a formation of trace quantity of thorium oxalate. So this solid mixture of the lanthanum oxalate and trace quantity of thorium oxalate, it is then boiled with ammonium oxalate solution. So sufficient quantity of ammonium oxalate solution is added to this solid and mixture is boiled So after boiling, this solid thorium oxalate, it gets dissolved and infiltrate. There is a formation of there is a thorium oxalate which is removed by means of filtration, and solid mainly contain lanthanum oxalate. So lanthanum oxalate, it is remain insoluble even it is boiled with ammonium oxalate. So there is a solid which is lanthanum oxalate, and in filtrate there is a thorium oxalate. So after filtration, again solid is taken out, and filtrate it is processed for again isolation of or purification of thorium. Now solid is mainly contain lanthanum ions. So this solid lanthanum oxalate, it is treated with concentrated sulfuric acid, and there is a formation of paste of lanthanum sulfates. So these lanthanum sulfate paste, it is again leached with water, it is diluted, and there is a formation of clear solution of sulfates of lanthanides. So from this clear solution of sulfates of lanthanides, lanthanide ions are separated. Actually, this clear solution contains mixture of lanthanides. There are different lanthanide ions present in this clear solution. So one lanthanide, it is separated from the others by applying the separation methods like ion exchange method, solvent extraction method, etc. So in this way, by two steps, monosite sand or monosite mineral, it is converted into clear solution of sulfates of lanthanides. So in first step, concentration of monosite is there, and in second step, chemical treatment is done. In chemical treatment, mainly first of all, mineral is treated with sulfuric acid, then it is leached with water, then it is treated with sodium pyrophosphate, then especially filtrate containing lanthanum sulfate, it is treated with oxalic acid to get solid of lanthanum oxalate, and finally solid lanthanum oxalate, it is treated with concentrated sulfuric acid to get the sulfates of lanthanides. So in this way, monazite sand from monazite mineral, there is a formation of clear solution of sulfates of lanthanides. In next video, we are going to discuss how lanthanides are separated by using this clear solution of sulfates of lanthanides.